Have you ever looked up at an airplane soaring through the sky and wondered, how does that massive hunk of metal stay up there? It seems almost magical, defying gravity with ease. The truth is, it's not magic, it's science. Airplanes fly due to a delicate balance of four fundamental forces: lift, thrust, drag, and weight. Understanding these forces unlocks the secrets of flight. Think of these forces as a team, each playing a crucial role in keeping the plane airborne. Let's explore each of these forces and how they work together to achieve the miracle of flight. Lift is the force that directly opposes gravity, lifting the airplane into the air. But how is this upward force generated? The shape of an airplane's wings is key. Airplane wings are curved on top and flatter on the bottom. This shape is called an airfoil. When air flows over the curved upper surface of the wing, it speeds up. This faster-moving air creates lower pressure above the wing. At the same time, the slower-moving air below the wing creates higher pressure. This difference in air pressure generates lift, pushing the wing upward. While lift gets the plane off the ground, thrust is the force that propels it forward. Thrust is generated by the plane's engines. Whether it's a jet engine or a propeller, the principle is the same: create a backward force. And according to Newton's third law of motion, for every action there is an equal and opposite reaction. An equal force pushes the plane forward. Think of it like swimming. You push water backward with your arms and legs, and that propels you forward. Similarly, the engines push air backward, propelling the plane through the air. The faster the air is pushed backward, the greater the thrust generated, and the faster the plane moves forward. Section 4. The resistance drag. As the airplane moves through the air, it encounters resistance. This is drag. Drag is the force that opposes the motion of the airplane through the air. It acts in the opposite direction to thrust and slows the plane down. Drag is caused by the friction between the airplane's surface and the air molecules. The shape and size of the airplane, as well as the smoothness of its surface, all influence the amount of drag it experiences. Streamlined designs and smooth surfaces help reduce drag, allowing the plane to fly more efficiently. Section 5. The pull of gravity. Weight. We all experience weight. It's the force of gravity pulling us towards the center of the Earth. Airplanes are no exception. Weight is the force that pulls the airplane downwards, opposing lift. The heavier the airplane, the stronger the force of gravity pulling it down, and the more lift is needed to overcome this force and keep the plane airborne. This is why different types of aircraft have different weight limits. Exceeding these limits would make it impossible for the plane to generate enough lift to counteract the increased weight. Section 6. The dance of flight. So, how do these four forces work together to make flight possible? It's all about balance. For an airplane to fly straight and level, these forces must be in equilibrium. Lift must be equal to weight, counteracting the force of gravity and keeping the plane aloft. Thrust must be equal to drag, overcoming air resistance and maintaining a constant speed. When these forces are balanced, the airplane can maintain a steady altitude and airspeed. To climb, thrust must exceed drag, and lift must increase to overcome the increasing weight as the plane ascends. To descend, the opposite occurs. Thrust is reduced, and lift is decreased. It's a delicate dance of forces, constantly adjusted by the pilot to control the aircraft's movement. The next time you watch an airplane soar through the sky, remember the interplay of these four forces: lift, thrust, drag, and weight, working in perfect harmony to make flight possible.